This poster addresses our preliminary investigation into the applicability of 30 MHz RF to the extraction of water from icy lunar regolith at JPL. On the second slide, we address the approach used in which we designed a reactor and a system that could be used for operating at low temperature and pressure, while including the ability to monitor these variables to observe the dynamics taking place during the tests and to help understand the feasibility of using RF for this purpose. On the third slide, we describe the variables we have included in our operation, those being the preparation of ice particles in a lunar regolith simulant, a reactor design that permits removal of water vapor during RF application, and measurement of temperatures and pressures in real time within a system that maintains continuous vacuum and RF application while operating within a cold environment, that is, -20 centigrade. On the fourth slide, the reactor design used in our tests is shown. The central stainless cylinder is porous, it's about 6 inches long, to apply the extraction of water vapors via applied vacuum as they are generated while applying RF across a 1 centimeter annulus of 5 weight % ice in JSC 1A simulant, and simultaneously monitor temperatures both within the icy regolith material and on the outside wall of the stainless reactor cylinder. On the fifth slide, a picture of the system setup in a -20 centigrade cold room is shown. The reactor cylinder is placed in a tub of regolith material that maintains a constant temperature environment to permit measuring a temperature differential across the reactor boundaries from the central cylinder through the icy material to the outside reactor wall. Individual U-traps in series within the vacuum line allowed us to capture water at different times during the application of RF in order to help correlate temperature, energy applied, and degree of ice sublimation. On the sixth slide, data is shown which illustrates the dynamics associated with the application of a constant 12 watts of RF applied across the 1 centimeter annulus in the reactor. The first 2 hours showed a slow change in temperature from about a -20 to about a -10 degrees with a pressure below 1/10 of a torr. External wall and internal material temperatures were relatively the same. An abrupt change in internal temperature of about 15 degrees and a pressure increase were observed at that point that resulted in the temperature increasing to a +10 degrees, but the pressure returning to approximately 6 × 10⁻²⁰ torr. Over approximately the next 100 minutes, the temperatures remained relatively constant, but different, both inside and at the wall of the reactor. The final 30 minutes resulted in a non-uniform temperature rise of 10 degrees within the material. In summary, on the last slide, we have demonstrated that the application of RF to icy regolith simulant material results in release of water vapor, a total of which over 4 grams were collected in 2 different temperature regimes during the 4.5-hour test duration. The test reactor design and system operation proved to be quite appropriate to use in further tests to help understand the thermal, transport, and energy absorption dynamics that could potentially be applied to lunar operations.